Welcome back to Computer Science 4300. Today is Tuesday, and we're going to be talking about one of the most important things that is often overlooked when it comes to video game programming, and that is talking about game tools. Game tools are incredibly important because without them, authoring our game, making levels, making assets, all that kind of thing, would just be far too time consuming. You couldn't possibly do it. So game tools are very important, and as part of your project, you have to implement a level editor. So as part of this lecture, I'm going to show you sort of the first steps on how you would make the level editor for your game for the class. And so we'll talk about drag and drop and how we can implement drag and drop inside our current game engine. And I'm also going to talk a little bit about game saving and loading, because there will be some sort of progress that you have to save in your game for the project. And so let's talk a little bit about that too. So here we go. Let's get started on the lecture. So lecture 16, we're talking about game tools, drag and drop, as well as game saving and loading. So what do I mean when I say game tools? So as you make more and more games, what you're going to quickly realize is that programming is not necessarily the bottleneck. It's actually content creation. And it's one of, if not the most time-consuming aspects of video game development, is allowing yourself to not only create, but iterate on designs for your assets and your levels, etc. really quickly. So tools are programs that assist us with creating content for our games. Many tools exist that help us, for example, with general asset creation. So for example, there's Photoshop, Blender, pixel art, Notepad. That's a tool, right? Lets us edit stuff. But for more specific asset creation, for example, maybe maps or levels, we may have to construct our own tools to help us. Okay, so there's some things like textures. Of course, there's lots of texture editors like Photoshop and stuff out there. But for things that are more specific to our game, we may have to enter the realm of tool authoring in order to get those tools for us to create our games. But first, let's talk about popular existing game engines. Several really popular game engines already exist. So for example, Unity, Unreal, Game Maker, Godot, lots of game engines are out there, and they already come with some tools that help us create content. These game engines are more general, so what I mean by that is they help you make the entire game. This course, however, is all about game programming, so we're not just using an editor. That would be cheating, right? We want to kind of create our own game engine. But these engines do a great job of illustrating the power of tools for game creation. So for example, here's an example from Unity. And in this example, we have a level editor that someone has created for their game within Unity. And you can see that they're very easily and quickly able to drag and drop these Minecraft-like blocks into their level and create a level, like creating a little river here, filling in some ocean, etc. And you can just think of how long that would take to manually place water tiles in a text file like we did for our assignment 3, etc. So these games, these tools for authoring content for games are just a lifesaver when it comes to how quickly you can edit the content for your games. Here's another one from Unity where you are able to look at your game world and edit it in real time. So this is sort of a road drawing, so path drawing. And what you do is you come over here and you enable texture painting, and it allows you to select a texture and then paint that texture in your game world. And so you can just think of how long it would take to do something like this, or something like this, if you had to sort of manually create your own vertices and edit them, right? So these tools for editing content in your game in real time. Like, for example, here's another tool that lets you select vertices of a road, and then the game engine will paint the road for you. And you can see things like trees and rocks popping in and out as that road is edited. But just think of how long that would take you to make one small change to a road if you had to like manually edit these things in a text file, for example. So it could be a lot of work. Also, so I'm pretty sure this is from the Godot game engine, and a lot of game engines nowadays have tools for visual programming and visual data manipulation as well. So what this is called a blueprint. And so lots of game engines use blueprints these days, and they allow you to sort of drag and drop these properties such as colors, alpha values, other variables, and create links between different variables within your system. So here, for example, we're assigning a color to this texture, we're turning on or off the RGB, and we're able to see this sort of tool chain that goes through the logic of applying certain colors to certain textures in the game. So this is also something that could end up saving you a lot of time. However, if your game is not using a pre-existing engine, then you have to create your own tools, right? These game engines that I'm talking about, Unreal Engine, Godot, and Unity, they're a relatively new phenomenon in terms of like overall the lifespan of video games, right? Video games have been around since like the 70s, or even, well, actually a bit earlier. And so there haven't always been tools to make your games. So many existing games, especially older games, sometimes come with editors or tools, or both, for modding or creating your own custom content. And the features and powers of these tools vary wildly from game to game. Excuse me. So this is the editor that came with the video game Warcraft 2. And I remember using this editor when it was new, and it was mind-blowing. You could paint your own maps, you could like create your own NPCs. It was truly amazing, like the power this gave you. Now, for the most part, it was limited to really, really basic triggers and sculpting of a level. Also editing the properties of different units in the game. So while it was very powerful, it was nothing compared to what we have in some level editors these days. So I remember having hours and hours of fun creating my own levels in the Warcraft series of games. And it was all because of them just having the foresight to include the level editor that they use to make their game for the user to actually use to create their own levels as well. This is an example of a map editor for the original game, or for Doom. So this was not released with the original version of Doom, but as soon as Doom came out, people realized that it was very, very moddable, and it was very fun to play, and people got pretty bored with the original levels. They finished them so quickly, so what they wanted to do was make their own levels. And so id Software did not release an official Doom map editor. They did later on, but it was like a decade later. And so what people did, like fans of the game, was create their own Doom level editors. So these WAD files were the level files that Doom shipped with. And for example, Doom Builder was just one of the map editors I used to use back in the day to try and create my own levels. Then came along more 3D games. This is a Quake level editor. So the level editors for Quake were awesome because you got to like fully sculpt things in 3D. And these editors like introduced a bunch of tools, like you could carve out walls, you could have secret passages, edit the properties of any texture or any surface in the game, put in like the spawn locations of everything, all the weapons, change the ammo. Some of these also let you edit the code for Quake itself. So actually, the first programming I ever did in my entire life wasn't a programming course. I didn't even know how to program at this time. But what I did was I downloaded the Quake source code, and it was written in a language called Quake C, which was a stripped down version of the C programming language. And I just looked around the source code. I didn't know what any of it really meant, but I saw variables like gravity or damage or run speed and stuff like that. So I would just look at the source code when this came out, look for something called gravity and turn the value down. And all of a sudden now I'm like floating in the game, right? So it was really cool how these tools, well, they got me jump started on my fascination with technology and with programming and with gaming in general. So this is one for Quake. This is the Warcraft 3 level editor. And this editor is where, at least for 2D games like Warcraft or for RTS games, it really had a lot of power in the level editor engine. So if you're asking like how much power, well, you could almost arbitrarily program with the scripting engine that they released for this game. And it turns out that Dota, Defense of the Ancients, the original Dota game was made completely within the Warcraft 3 world editor. So like they created a new game. That's how powerful this engine was. And Dota, it wasn't the first MOBA game. The first MOBA game, from what I could find, was a map made in the StarCraft level editor. And, what was that called? I have that in my other lecture. Oh, I wish I could remember that. So it was a Dota-like game, but it was very, very simple, and not a lot of people played it. And so when the Warcraft 3 editor came out and made it much more complex and had nicer rules and nicer game mechanics and stuff, that's when the MOBA genre was really launched. And just like the top grossing video games like of all time, like League of Legends, Dota 2, they all came. Aeon of Strife, thank you. I have that in another lecture. I forgot that. So Aeon of Strife was the first MOBA-like game that I could find. That was made in the original StarCraft engine. But just think of like Dota spawned one of the biggest video game industries, and it was just made by some dude, right? Someone had a good idea, and the company released the tools to allow that person to implement the good idea. So games don't do that anymore, right? Companies don't give a shit about you anymore. They just want to make their dollar and move on. And I get very upset when I think about how Blizzard has become what it has become. But like Blizzard used to be really awesome, and releasing tools like this really showed the fans that they cared about the fans, right? However, the StarCraft 2 editor was even more powerful than the Warcraft 3 editor. So I'm not saying that Blizzard completely gave up on their fans, but the StarCraft 2 editor was one of the last truly great things, in my opinion, that they did that was really just for the community, right? And like people made a World of Warcraft clone in the StarCraft 2 editor. Like that's how powerful this one was. So the whole point of this being that tools are awesome. Not only do they make you able to author content for your game faster, but if you give them to your fans will do things like create Dota and play your game forever, right? So it's really cool. Now, in more recent times, we've gotten things like Super Mario Maker. So if you've never played Super Mario Maker, I highly recommend it. The entire game essentially is the older sort of retro Super Mario mechanics, but you can edit your own levels, upload them online, and have people play them. So the entire game really is the level editor, right? And then you're able to play your levels. And this is sort of what you're going to be doing for your final project. Now you might ask, okay, that's a bit of a tough ask. Like that seems like a lot of work. But hopefully by the end of this lecture, or actually by the middle of this lecture, you'll see why it's not that much more work than you've created already. This is something that I wanted to show, which is actually pretty amazing. And it's a tool called SpeedTree. So SpeedTree it lets you make trees. Cool. Well, you might think like that's not very powerful, but this is one of my favorite examples of how you can specialize in something and do it so well that you can create a company out of it. So this group of people created SpeedTree as a plugin for a level editor, and it became so popular that they started releasing it for other level editors. And essentially what it does is it parameterizes tree making for your games, and to the point where you can say, I want a forest of trees that have this sort of general type, like the leaves change with the seasons, they fall at this rate. Like I want fat trees in this area, skinny trees in this area, leaves with lots of foliage over here, and the thing just does it for you, right? So it's become so popular that people basically don't make their own trees anymore, right? They just use SpeedTree because it's just so good at what it does. All right, so how the hell do we do this, right? It's making the tool is almost as much work as making the game itself. So game tools are typically made alongside a graphical user interface, so a GUI, which includes some sort of menu system. So in this course, we're not going to be implementing our own fully functional GUI, but we can still implement some tool-like interface. The first step to implementing our level editor will be a drag and drop system. So what is drag and drop? Well, everyone is so familiar with it now, it doesn't really need a definition, but drag and drop typically refers to the ability to move an on-screen UI element from one place to another place with the mouse. In order to implement a basic level editing tool for our games, we can implement drag and drop via ECS. Okay, so let's create a draggable component. So here's a drag and drop variant that we can program really easily into our game engine, and I'm going to show you how easy it's going to be. So literal drag and drop would implement the following. So when we're thinking about dragging and dropping, here's the sort of literal interpretation of that. So when we click our mouse down, we would start to drag an entity. As our mouse moves, our entity moves with us. And when we release the mouse, we let go the entity, okay? That ends up being a little bit cumbersome because when you're trying to like fine tune the placement of something, you actually don't want to have to hold the mouse button down for so long. So here's the drag and drop variant that I'm going to implement during this lecture. So this is kind of annoying in practice. So instead of drag and drop, we're going to implement pick up and put down, okay? So when we click the mouse down, we're going to pick up the entity. As the mouse moves, we move the entity with it, and then we're going to click on the final location and just let go. So it's sort of picking it up, moving it, and then putting it down. So the way we're going to do this in ECS is via the following. So we're going to implement a draggable component. See how ECS is going to make our life really, really easy here? So the draggable component is going to be something that we can attach to an entity that lets it be draggable. Really easy. So if we want something to be draggable, we put the draggable component on it. And so we can have this, the only thing we need in the draggable component is a Boolean, which indicates whether or not this thing is currently being dragged. Done. So this is our component. So now what we're going to do is we're going to implement something that looks like this. So inside our input system, we're going to say if the left mouse button is pressed, we're going to say, okay, auto E equals get the closest draggable entity to the mouse click position, right? So this is a function that you would write. And then whether or not it's dragging, so you're going to have a little Boolean reference here, which is, okay, I'm going to get the draggable component of that entity that's closest and get its dragging variable, which is whether or not it's currently being dragged. So if D is true, whenever I click the left mouse button, that means it's currently being dragged, so I'm moving it around. So if I'm dragging it around, I'm going to click fall. I'm going to turn off the current dragging. Otherwise, if I'm moving it, if the entity currently is not being dragged, if I clicked inside E's animation, then I'm going to set dragging equal to true. Then, inside my drag and drop system, if for each entity, if it has a draggable component and I'm currently dragging it, set the position of the entity to the current mouse position. That's it. So let's go do that. I'm going to do it live. I haven't practiced it, but I'm pretty certain I can do it live. All right, so let's go over, this is my assignment 3 solution code. So there's, don't try and pause this to try and get to scam your way into a solution. But the first thing I need to do is remember how our scene, so let me just run this code so you can see that it's just assignment 3. So I'll run it here. Okay, so I'm running it. This is assignment 3, nothing special here. I can't, clicking and dragging doesn't do anything right now. Just moving around as assignment 3 does. So I have to include mouse actions now. When we looked before at assignment 3, our actions in the game just had a type and a name, right? So there was like a type, which was starting or stopping, starting or ending. And then there was a name like jumping, move left, move right, etc. So now I'm going to update my action class so that I've included the ability to take in a position for the action class, right? So if you think about it, a mouse click is not just a mouse click, there's a position associated with it. Moving the mouse also has a position associated with it. So we're going to pass in here, we're going to have, this is all that I've done here, is I've just updated the action class. So what we can do now is we can construct an action based on a name. So for example, it might be a left click or mouse move, and it can also have the position of that event within the window, all right? And then I've just updated the C++ code to allow me to create an action here. There's nothing really special. I've just added the ability for an action to hold a position as well. But whenever I say like jump or move left or whatever, I'm not going to use that position. I'm only going to use that for the mouse. The last thing that I did here was, just so I wouldn't have to remember any of this syntax, is I have put my mouse event code into the game engine. So before, when we had our user input function, our user input system here in the game engine class, all I had was key pressed, right? Oh, sorry. I had key pressed or key released. And that did the thing where it looked up to see in the scene whether or not it had that action mapped to a key. And if it did have it mapped to a key, then it would just send it to the engine. However, mouse events are always going to go through. So let's just look at what I have here. So whenever I have a mouse event, I'm going to first record the mouse position. So here, this just says mpos equals sf mouse get position within the window. So this line of code here just gives me the XY location of the last mouse event, whether or not that was a click or whether or not it was a move. Then I'm going to create a vec2 out of that mpos. Okay, so that's because that we're working with vec2s, and this one ended up being an sf vector2 I. So I've gotten the mouse position from the mouse action. If it was a mouse button pressed, then what I'm going to do is switch based on the mouse button. So if it was the left mouse button, then my action is simply going to be left click, start, and position, right? So the action just says, okay, this is a left click. I'm starting the left click, so the button is going down, and I'm currently at this position with the mouse press, and then I break. And I do the same thing for the middle click and the right click. Because remember, my gameplay scene doesn't know anything about where the input came from, right? So it doesn't know if it's from a mouse, it doesn't know if it's from a network or whatever. And so I'm giving it these actions specifically because our scene should never know that things came from a mouse or whatever. I do the exact same thing with mouse button released. Okay. And by the way, so if you're looking at this and you're thinking, okay, maybe I'll do something similar to this for the project, for the level editor, you can literally just pause the screen here and type this code into your game engine class. I don't mind that you copy this code for your project. Okay. And then the last one here is the mouse moved event. And that is just mouse move. And then there's a little bit of special code here where you have to actually get the mouse move event or mouse move position from the event itself. And mouse move is a bit of a special event because it doesn't actually have a start or an end. It just is, okay? So for mouse move, it doesn't have a start or an end, unfortunately. Okay, so now that we have that, we've updated our action and we've updated the game engine so that we now have these new actions that are based on mouse clicks rather than on keyboard input. So let's go over to the scene play. And what I want to do initially is let's just see if the event is working, because I haven't tested any of this, right? So I'm going to go here and I'm going to look at, okay, let's look at the starting of a left click action. So I'm going to go up here to the starting code, right? This is my solution to assignment 3, but it doesn't really give you much, okay? So I say else if action.name is equal to left click. All right, so if this is a left click start, then I'm going to standard cout left click, and then over on my action here, I have a toString, and toString is just going to print out the name of the action, the type of the action, and the position of the action. So I'm going to be able to say action.toString, and then I can print out a new line, and then we're done. So if everything went well, now whenever I left click inside my game world, I'm going to be able to see in the console left click and then some information about it. So let me go over here. Let me, properties, I'll turn this up a bit. So let's put it at, say, 20. So that's a little bit bigger. So now nothing is happening when I left click in the menu scene, because remember, I put it on the play scene. Now if I go into Mario and I left click, there we go. So you can see that I'm left clicking at different parts of the world. Okay, so you can see that now. Perfect. All right. So let's do a little thing now where we output the mouse position if the mouse was moved. So down here, I'm going to say if this is mouse move, I believe. Let me go back to my game engine. Yep, so this is mouse move. And so this is mouse move. And I'm going to print out action.toString as well. So now this should print out whenever my mouse actually moves inside the window, right? Okay, look at that. So we're printing it out. We know that the mouse move works. So now what I'm going to do is I'm just going to delete that, right? Because I don't want this to be spamming to the output. Next, what I'm going to do is I'm going to make a little circle that gets drawn to the screen wherever my mouse is, right? So this will be my debugger to know that I'm clicking in the right place or not. Because, as we remember, there are actually two coordinate systems going on here. One is the screen coordinate system, and the other one is the level coordinate system. So we want to be able to debug to make sure that the place that our mouse is on the screen matches where it is in the world and not just the screen coordinates. So let's have an SF circle shape. This is going to be really basic. I'm just putting it in as a class variable inside this scene. So this is going to be mouse shape. Okay, so SF circle shape, mouse shape. Now I'll go back to this. And in the init functionality, what am I going to do? I'm going to say mouse shape dot set radius. Yes, set radius. I'm going to have a radius of 8. I'm going to say set points, set point count. This is going to be 32. So that just makes it a bit of a smooth circle. And let's say set fill color and make this SF color. Let's have this be red. So we have 255.00. And let's make it a little bit transparent so I can see through it to know that I'm on top of the correct thing. All right. So that's, oh, and I also want to set the origin, set origin equal to 8, 8. And the reason for that is I want the position of the circle to be the center of the position, not the top left of the position, okay? So if our radius is 8, then we want to offset that by 8, 8. The last remaining thing that we have to do, and I'll do it down here. So if I go down to, let's do action, all right? So whenever I move the mouse, I'm going to say m mouse shape dot set position, and then I'm going to set the position to m mouse. Oh, it's the position of the action, right? So action dot pause dot x, action dot pause dot y. Cool. So whenever I get a mouse move action handed in, what I'm going to do is set the position of that shape to be drawn. And the last thing I need to do is down here in the rendering. And in the bottom of the rendering, what I'm going to do so that it appears on top of everything else is I'm going to say, what is this? Did I pass in a render? So it's m window game. Yep. Okay. So I'm just telling the game window dot draw m mouse shape. Oops. Okie doke. So, and please, if you're out there in the chat, if I'm moving a little bit too fast, I apologize, but this is, I'm recording this, and then you can go back and watch the recording later. But I just want to make sure I fit it all in. But hopefully you're following along so far, if you're not understanding every little bit. Okay, so you can see that now, whenever I move my mouse around, I have this little red dot that's on it. Okay, and that kind of shows me where my mouse position is at any time. However, I'm anticipating a little problem here when I run to the right on the screen. So my mouse position is perfect now, but watch as I run to the right. Uh-oh. This doesn't look right. And why is it? Why is that? It's because as Mega Man moves, the camera view moves along with Mega Man. Right? So what I actually have to do here is not just get the relative position of the mouse within the window, but I have to add the X value of that to the actual view of the camera, right? Because the left-hand side of the view of the camera is moving as Mega Man moves. So I have to take that into account when I do this. So let's just take a second, and we'll come down here, and we'll actually, oops, where am I? I'm in the action code now. All right. So down here, I can't just take the action's position because the action's position was relative to the window. But what I actually want is the game world position. So let's have a look. So here's the window, get view. So this is the get view of the window. Now, the center of the window, so I'm going to say float x equals get view dot get center dot x, right? So I'm going to have this value of x. This is currently set to the center of the window. But what I actually want to do is I want to get the left-hand side of the window, right? So if this is the center of the window, then the left-hand side of the window is going to be this minus the window dot size dot x over 2, right? So this here is the center point of the window minus half the width of the window. So this is, I'm going to call this x diff, because this is the difference in the x value from the window's point of view to the world's point of view. So if I take this xdiff now and I add it to the window relative position, okay, and like I said, I have not tested this before, I should have what I actually want here. So it's working right here, and as I move Mario through the level, okay, it's keeping up with me. Now you can see sometimes that it's not moving with me, and the reason for that is that the mouse isn't moving, right? And the position of this point, this circle only gets updated whenever the mouse actually moves. Okay, so I could put code in there to update this whenever the actual update function is called, but for now this is good enough. Like whenever I move the mouse, it's actually updated. But for your level editor, you can go ahead and add that little bit of code that would fix this position whenever Mega Man moved, or whenever the viewport moved, rather than just when the mouse moved. I just wanted to show you how to translate the coordinates for this game into, or for this window into this game world. Now, for assignment 4, you would have to do this for both the X and the Y position, right? Because the X and the Y position are changing. However, that's not too difficult because all you would need to do is just copy this in here, and then you have the Y difference, and this is the Y, and this is the Y right here, okay? And then you'd add Y diff like this, and this code will actually work for my game as well, because the Y value is not actually changing, right? So the code I just wrote should work for pretty much any game, because it's taking both the X and the Y into account. But you saw how, because our game engine here is only changing the X value, that you wouldn't need to change the Y value as well. But we might as well put it in there just to be more robust. All right, so the next thing we want to do is whenever our, so what we have to do first is go over to our components and create a draggable component, okay? So if we want things to be able to be draggable, let's go over to our component class and let's create that draggable component. So this is draggable, it's a public component. It has a public bool dragging equal false. And then we have a C draggable. All right. So here's our draggable component that just stores a Boolean of whether or not we are currently dragging this component, right? Or the entity that contains this component. Now what we have to do is we have to come over to our entity class, and because we have a new component that we want to store in our component tuple, we just have to add C draggable to the entity. Okay, so that we don't get template errors whenever we go to implement our new draggable component. So now we've added a draggable component to the entity just by adding the component and then adding it to the entity. So that's there now. We have access to a draggable component. So in the scene play, what I want to do is whenever I left click something, I want to loop through all my entities and I want to see whether or not where I clicked, was it inside any given entity, okay? So let me go over here real quick. I'm going to see what solution code I have. Okay, no, I do not have solution code for that, so that's a function that I have to write. Alrighty. So what I'm going to do here is essentially say for auto E in m entity manager.getEntities. So for every entity, what I'm doing here is check to see if any entity was clicked at this position. So I'm going to have to go down to my mouse position code and actually get this again, because I need to get, remember, I need the X and Y difference. All right. So I have to do this again, and then I can say vec2 world pause, if you will, equals, and this is going to be action.pause.x plus xdiff, action.pause.y plus ydiff. Okay, so this position here, this is where we actually clicked inside the world of our game. Perfect. So now I need a function which tells me if I have clicked inside an entity, right? So let's see here. Let's just write the function up here. I'm not going to make it a part of the scene. I'm just going to have a global function for now. This is going to be bool is inside. And I'm going to take, let's see here, a vec2 position and a standard shared pointer entity e. And this is going to return true if it's inside another entity. Now, if you give me a second, I'm going to magically make that code appear because I don't want to take so much time to write it. I wrote it in another code base and I just want to copy it over. And I'll explain it, but I don't want to have to write it all. All right, here we go. Here we go. Boom, boom. Here's the code. I had it inside a previous physics system. Okay, so standard shared pointer entity E and is inside. All right, so let's look at what this does. If the entity doesn't have an animation, so if nothing is being drawn for this entity, then we can't have clicked it, right? We're just going to say that. So if it doesn't have an animation component, return false. Otherwise, we're going to get the half size of the animation. We are going to get the delta, so the vector distance between both the entities, or I guess between the position and the position of the... So this is the position of the transform of the entity, and this is the position of the click, okay? And I absolute value those. So for example, if I was -3 in the x direction and +7 in the y direction away from the center of the entity, then this is going to be 3, 7. And what this does is it just says if how far away I was with the click is less than the animation size, and in both the x and the y direction, then I've clicked it, right? So, okay, what did I do? I did this. I said, here's my entity. Here is the position of the entity right here in the middle. Maybe here is where I did the click. Okay, so I measure this distance, that's dx. I measure that distance, that's dy. I absolute value them, so they're both positive. And then I just say, if the x difference was less than the half width of the entity, and the y distance was less than the half width of the entity, or the half height of the entity, then the click was within the entity. All right, very simple. So this is what that code does. Now, whenever I mouse click, what I'm going to say is the following. So if, let's see here, is inside world pause, right? Because that's where I clicked in the world. So, and E. So this is saying if I have clicked inside this entity. All right. So what do I want to do if I've clicked inside the entity? Well, at the very, all I want to do really is change is dragging, whether or not it's being dragged, to the opposite of what it is. So if it's not being dragged, I want to start dragging it. If it's currently being dragged, I want to stop dragging it. So I also want to check to see if this entity has a draggable component. So if E has component, C draggable, and is inside, right? Because if this entity doesn't have a draggable component, we don't care about it. We're not doing any of this logic to it, right? And so now we check. So E has component, or get component, C draggable, dot dragging equals not that thing. right? So we get whether or not it's dragging and we negate it. So if it was positive, now it's true. If it was true, or if it was positive, now it's negative. If it's negative, now it's positive. If it's true, it's false. It's false, it's true. Okay? So we change the entity from dragging to not dragging, or vice versa. And what I'm going to do here is let me also, in order to debug my code, because we want to debug it as we go along, I'm going to say standard cout e tag. So I'm going to say entity clicked, and then the tag. And then what I'm going to do is, if this is true, I don't want to be able to pick up overlapping things on the same click. So I'm going to just break out here. Okay, so that if two things happen to be overlapping, I'm only going to pick up one of them. So let's test my code so far. Maybe I've got some no, okay, so no compilation errors. That's a miracle. So I'm going to click over here. So I've just got the left click thing. Nothing's happening yet. Let's click on the cloud. Okay, nothing happened. What happened? Oh, I know what's wrong. Do you know what's wrong? Are you following along? Why isn't this printing out? Look at my code. Why isn't anything printing out? Oh, wow, someone's actually awake. Awesome, thank you so much. Add the component, right? So, up here, I don't want to give away too much of the solution code because the assignment still isn't due. So let's look at where I add some stuff. Okay, so this isn't giving away too much. So this is where I add decorations, and this is where I add the player and stuff. So this is just the file reading stuff. If you're not done this by now, then you had problems anyway. So what I'm going to do is I'm going to add component C draggable to my my decorations. I'm going to add it to my tiles, and why not, let's add it to my player. All right, so now that I've added the components, let's see what I actually have here. So if I click, nothing yet, okay? Let's click on this. Hey, I clicked a tile. Hey, I clicked a deck. Hey, I clicked another deck, but the player was on top of it. So now, hey, I clicked the player. Cool. So I'm actually clicking things. And if we turn on, where is it? What's the actual thing here? Yeah. There's the grid. What's the button for drawing? There we go. It's C. Okay. So if I draw the bounding boxes here, now I can actually see where I'm clicking, and as soon as I click within one of those things, it's actually clicking for me. Perfect. Great. So the clicking is working now. That's cool. That's step one. The only other thing that I have to do is, now technically what I should do here is I should add a draggable system. But I'm just going to do this in the movement system, just because it's way easier for this demo, okay? So let me scroll through my solution code here. I'm going to go to my movement system. Where's my movement system? Okay. I'm adding a whole bunch of code here so you can't see any of my code. This is hilarious. All right. So here's my movement system where I've created like a bunch of white space. Now, update dragging entities, right? So technically I should have had my own system for this, but let's just cheat for the demonstration. So for auto E in M entities, what I want to do, entities, oh, entity manager, get entities. All right. I want to loop over all of my entities, and if it's currently being dragged, I want to set the position of that entity equal to the mouse position. Okay, so let's do that. So I'm going to have, for each entity, if, now, okay, hang on a sec. C++ annoyance coming through. I've got to take my isInside function and then like put it up at the top so I can actually use it. All right, so I'm back. So what I did there was I took my isInside function and I added it to the top of this file because it's not in the header and I want to be able to call it from here. So if E has component C draggable and E get component C draggable dot dragging, right? So that means if it's true. So if it has a draggable component and it's currently being dragged, set the position of the component or of the entity to the mouse position. Now, technically what you should do here is you should have like maybe a vec2 here that holds the mouse position, but I've created this mouse shape. So I'm just going to grab the position from that mouse shape, okay? Because I've already got it, so why not? So I'm going to say E C transform. So get component C transform dot pos is equal to M. So this is going to be a new vec2. This is M mouse shape dot position dot X mouse shape dot position dot Y. All right. That should just work, hopefully, because we've just said if it's currently being dragged, set it equal to the same position as that thing. So let's update it and we'll see if she works. All right. Look at this. I'm dragging it around and I'm going to click it again and it, oh, perfect. Okay. So look, I almost have a level editor. And how long did that take? Not very long, right? And watch this. It interacts with the physics of the game engine in real time. How cool is that? Because it's actually happening like within the game engine, right? Isn't that cool? I think that's pretty cool. And oh, look, I actually can pick up multiple things. So what you can imagine now, if you want to make your level editor, just have something in there that, for example, lets you create a new object on a mouse click and lets you change the type of that object, right? So maybe if I scroll my mouse wheel, it lets me iterate through all the different animations that I have in the game. Or if I press the B key, it lets me put a brick in. Or maybe I have a little menu up here like Super Mario Maker that lets me drag something down into the level, right? And then all you would have to do is have some function that saves your level out to a file, right? And then you can load that level back in. So I've just done like probably half the work of the level editor for your game. All right. If this level is too hard like this, well then put some, and this could actually be a game mechanic too, if you think about it. Watch this. Let's do a cool game mechanic here. Let's move all the tiles, right? Let's say the game gives you this big ravine and you just have one block. So maybe you could do this and then you jump. Oh no. You jump and as you're jumping, you have to move the block over. Something like that. Like a really cool game mechanic that now is just like for free because ECS is so cool. I want to show you one other thing that's really excellent. So let me turn off my cheat enabler here. Okay, where is that? So what I'm doing here is I'm just removing the draggable components from my, whenever I'm removing them from all the entities. And now what you cannot see, because I don't want you to see my solution code, is I'm saying whenever a bullet collides with a tile, the tile is going to be given a draggable component. Okay? So all I did was I added one line of code that says whenever a bullet hits a tile, the tile is given a draggable component. So I haven't tested this yet, but let's check it out. All right. So I cannot drag this thing. You can see over here, right, that I'm left clicking, but I'm not getting the thing detected because there's no draggable component. So let me destroy this tile because it's gonna be destroyed by the bullet anyway. So let's shoot a bullet at this question mark that I can't currently pick up. So I shot a bullet at it. Now when I click it, I can drag it. Right? Game mechanics for free. ECS is incredible. One line of code. Like, imagine implementing that without ECS. Whenever I shoot something, I can drag it now. Like, isn't that crazy? Like, you could like envision some sticky glue or something in your game that like shoots bullets, and now things can be grabbed by the mouse cursor. Like, absolutely ridiculously cool stuff that you can do. All right. So that's all I want to show about that, because I've basically done the drag and drop system for your game for you, right? So let's get back to the lecture now. And, you can breathe a sigh of relief that you don't have to implement that for yourself, because it's basically done. All right. Lecture time. Let's get back here. So that was the draggable system. You see how easy that is to do. ECS makes it's just so deliciously easy. All you got to do is modify your action class and your game engine to now accept mouse events on top of keyboard events. All right, the last thing I want to talk about today is game progression and game saving, because your game engine is going to have some sort of way of having progression in your game, right? So a vital part of any game is the ability to save the player's progress at some point in the game. Games can be saved in a number of ways, and save games can also be stored in a number of ways. So for example, maybe you have a local file, maybe you have some cloud save like on Steam, you have a temporary save like in RAM that gets erased whenever you reset, or maybe if you're really old school, you have a password reset, right? So, that's really weird. Let me edit that. There we go. Okay. So that slide was supposed to come down like this. So games can be saved in any number of ways. They could have like a file save, a quick save, a checkpoint, whatever. There's a bunch of different ways you can save your game. So when you allow your players to save their progress, that's a game design decision, right? As the programmer, you're not necessarily in charge of that choice. So there's different ways that you could allow players to save the game. So for example, you could allow them to save or load whenever you want, right? So if you've ever played like a first-person shooter game like Half-Life or Quake, or I know I'm completely dating myself here, but there's usually like a quick save button. Like you can go hit F5 and it'll just save the state of the game. Then you can hit quick load whenever you want, and it will instantly teleport you back. Even if you're like mid-rocket jump, the quick load will take you back to that exact state. Another way is to save after some sort of mid-level checkpoint, for example. So save after a level, meaning, okay, I'm going to record that the player has beaten levels 1, 2, and 3, and then when they beat level 4, I'm going to save it to the file that they beat level 4. Or maybe there's mid-level checkpoints, like in Super Mario World for the SNES, right, where you can save your progress midway through the level. Or maybe you only want to be able to save at specific locations, like if you're in a town, if you're at a camp in the wilderness, which is like by design supposed to be inconvenient for the player, right? You don't want players to be able to save right before their attack hits to see if they can reload for the crit or something like that. You want them to be able to, there's got to be some sense of danger without infinitely reloading the game. So saving between levels is probably the easiest way to implement game saving, right? So when there's no entities currently active in the world, all we have to do is like store a list of the levels that you've beaten. Super easy. In simple games, like if you don't have quests, you don't have inventories, items, we can just save the level number that we're on, the level number, and then we're done, right? So for example, you could do that in your project. If you've beaten the first 2 worlds, you just save 1 and 2 to like a progress file. And then when you go to like load the game, you see their progress and you load, okay, they've beaten worlds 1 and 2. So now they're on to level 3. But if you think, okay, if there were some quests or maybe they had items in their inventory or whatever, then this gets a little tangly because now you have to have more and more information in your save file. how would you display your progress? So the progress has to be conveyed to the user somehow so that they can continue their progress, right? So for example, the simplest way for this is in like the original Super Mario Brothers or old arcade games. You just say you're on level 20, you're on level 1-2, you're on world 6, right? Just display the level number. So here's an example of that in Donkey Kong. You've got your progress, which are your points up in the top left here. You've got a high score being kept, and you've got L1, so you're currently on level 1. Or Super Mario World, you're currently in World 3, level 1, so you're just displaying that progress to the user somehow. Another common way is to display some sort of like overworld map, which conveys a deeper sense of immersion or world or progress to the user. Like, this is fine. It really does tell you where you are, but it's not very immersive, right? So some of my favorite examples of this would come from like Donkey Kong Country, where, you've got this like backdrop of the world that you're moving through. And then here you have like Funky's Flights or like Cranky's Cabin. And here you've got like a boss level and a normal level. And you're actually sort of on rails guided through these levels throughout the game. And then you're going to hit the button and you're going to go into that level. Right? So this overworld progress scene would be one scene in your game. And in that scene, hitting left, right, up, down, or a button is going to like move you on the mini map. And then when you select a level, somehow that level is encoded inside your game engine and you go load that level and then the player loads it. Over here, we have Super Mario World, which has an even bigger world map with all its 96 levels to play on. Here we have a more modern example of an overworld map with Cuphead. So Cuphead has some deeper things on the game map. It has some story elements. It lets you see which weapons you've unlocked by, pausing and selecting the menu and stuff like that. So there's lots of different overworld ways that you can do an overworld. Here we've got Path of Exile from a few leagues back. And sometimes progress can be really complicated. This game, if you've ever played Path of Exile, you know what I'm talking about. You've got like hundreds of levels that you can complete in an arbitrary order, and then you had like shaper maps and all kinds of nonsense. Made me stop playing the game, how complicated it was. But it's some sort of visual way of indicating the progress in your game so that the player can they're adding to this thing, that you get that dopamine hit whenever you see a new level being completed in your map or whatever. Here we have hero progress from Heroes of the Storm. So for example, if you're a modern game, then you've got some like experience to go to the next level. At certain levels, you might unlock a new skin or a new ability or something like that. So you're displaying your progress, whether it's levels, game progress, character progress, experience points, microtransaction history, whatever it is, you're giving that to the user in a nicely displayed way to keep them playing because they want to fill all these bars, or at least if you're like me, you want to fill all these bars, right? And an RPG game, you may have like a save point, for example. So how would you implement some of these things? Oh, there's also like the most basic form. So I'll give some more illustrations of these ways. Is how you actually save the game while it's running. Right? So the simplest possible way to store users' progress or allow them to progress from a death or something like that is a continue system. So if you don't want to, or you can't implement like a full save game for your game, now you will be doing that for your project, you could let a player continue from a given spot. So for example, if a player dies, are they going all the way back to World 1-1? Or are they going to be able to like restart from the beginning of that level? Do they restart the level? Do they restart the world? Do you take their items? Do you take their gold? Whatever, right? It was very, very common to do this in earlier video games because arbitrary saving functionality may not have been like technically possible, but there's really, no excuse for this sort of thing in modern games. So here we have, who can tell me what game this is from? Right? Like one of the first games to have true save game functionality allowed you to save your game, all the items that you had. Okay, a bunch of people saying Zelda. Thankfully, there's people out here who may have been born before like 3 years ago. No, not quite Undertale. That is the original Legend of Zelda. I'm pretty sure, unless someone can prove it's Undertale. I like these retro like arcade continue things. So back in the day, who in the chat has ever put a quarter into an arcade machine and actually played an arcade game? Because it's becoming increasingly rare these days. They wanted you to feel like a sense of urgency so that you didn't just quit and walk away. They want you to keep putting the quarters in. So don't let Hagar die in Final Fight, right? You've got to continue. Don't let the... And some of them would even say, like, you're a wimp if you walk away. In Street Fighter, you had, like, poor Chun-Li crying. Like, you know, you're not going to be a baby and walk away, right? You've got to put in another quarter and play again. And so these are kind of funny. But there's just, like, hundreds of different ways that people have made these sort of continue games and stuff. All right. So that's continuing in Game Over. That's one way you could do it, especially if you're doing a more retro game style. Save points. Save points make it easier to implement game saving and loading by limiting the places where a player can save and load. Typically, if you're in like an RPG, for example, or an action game or any game, save locations are away from other entities and dangerous situations. And they allow us to load a game without worrying about entity storage. Now, let me get back to that in a second. But also, save points are kind of a game design mechanic as well. So here's an example from Final Fantasy VI, one of my favorite examples. So you walk in here from the left, and you see this area. There's a save point, and there's a door to the right. So what do you know is going to happen as soon as you walk out the door to the right? Who's going to tell me what's going to happen as soon as you leave that door to the right? Just gonna wait a sec. There you go. So you know there's a boss fight coming, right? So a few people said, like, if you walk in here and there's a save point, and then there's another door, you bet your ass you're about to fight a boss on the other side of that door. Now, it's cool because they gave you the chance to save, right? So that if you die to the boss, you're not like 3 hours behind because you forgot to save. So it's like, it's this cool thing that draws you in, that you want to go interact with because it plays a cool sound, has a nice little animation. Like, all these things matter in ways that you may not have thought of. But from a technical point of view, this is also genius, okay? Because what they did was they made it so the save locations were deliberately in areas where there were no other entities around, right? So you don't need to save the location of the entities in this area because there are no entities in this area, right? You don't need to worry about what happens if you're saving and something hits you because nothing's going to hit you in this area. As someone else said in the chat, this is a safe room, right? It's a safe room not only gameplay-wise, but technically as well. From a programming point of view, this room has been specifically designed to make saving the game technically as easy as possible. So just keep that in mind with your games as well. And so save points are graphically appealing. They're places you want to be. They have pleasing sounds. Someone mentioned Vegas. Exactly. They have all the right bells and whistles for you to want to use it. In, who knows what game this is, right? The bonfires in Demon Souls, or Dark Souls. Also Demon Souls. So you have this bonfire, and saving at the bonfire would, it would save all your souls and all that kind of thing and where you were. But if you died, you'd also get to respawn from that bonfire location. And typically, also, not always, but in a lot of cases, these were also in similarly like safe locations. But there were some where you could actually abuse the bonfire to like get away from enemies. I won't go into that. Here we have two games that use the same sort of save game system. So here we have Super Metroid for the Super Nintendo, and we have Castlevania Symphony of the Night, And in both of these cases, there was like a room, another safe room type system. Like in Super Metroid, you'd come into the room and you were safe from any enemies and you could save your game, and you were technically safe to save the game as well. Checkpoints. Another way to save progress is checkpoints. So in level-based games, maybe you want to save progress within a level and not have them have to restart from the beginning of the level. And this reduces player frustration by letting them like get past a hard part and then have sort of like a breather where then they can then like continue on from later. But what it does is it lets you save the game mid-level, but it's not quite as powerful as a quick save or quick load, because with quick save and quick load, you can do things like manipulate RNG and stuff, and you don't really want the player to be able to do that. So here we have an example from Super Mario World. We have one from Sonic, and these are physical entities in the game that you would run into. So for example here, this is like the gate, the midway gate, and you run into it, and this is cool because it doesn't force you to take the midway point. If you don't want to take the midway point, you don't have to, because you could jump over it, right? So that's a cool gameplay decision. It doesn't force you to save midway. Same thing with Sonic. You could jump over the point if you wanted to. In Hollow Knight, you break these things to save your progress. I believe that's what this is. I'm sorry if it's not. I've never actually played Hollow Knight. I should be ashamed of myself. Technically, when it comes to checkpoints, they're easy to implement, right? So if the level just has a finite number of checkpoints, just store the checkpoint number along with the level, and you're done. So when a player enters a level, you spawn them at the position of the checkpoint that you stored them at. And then whenever you complete the level, you reset the checkpoints back to 0 or whatever. So what data do we actually want to save? It depends on the saving functionality that you have. For example, if you save after levels, or after bosses, or after big events, you want to save like the current levels you have completed. Maybe you save your inventory, you save your weapons. If you save at a save point, maybe you're saving the quests that you completed, the party and also the save point that you used, so that when you reload the game, you spawn at the correct point. If you use quick save, like quick save and quick load, you may have to save all of the information about every entity in the game, right? Because if you think about, I don't know if you've played Half-Life, but like as I'm falling and rocket jumping, I can hit one button to save everything. And then a year later, I can come back and load that save, and I'm still mid-fall, rocket is in the air, the enemy is still looking up at me. So you would have to save all of the information about all entities out to a file, and then read all of that information back and create the entities again when you loaded it. So how to implement loading a saved game depends what data was being saved. So if it's just items and levels, or like the level number or the items or your inventory, you can just recreate the game at the point before the level starts, right? You don't need to worry about saving the state of all of the entities in Super Mario Brothers, because you can only save the game after a level is ended, right? So you just say, okay, they're on 3-3 now, so when you go to start the game, start them at level 3-3, and however you would start that level. If it's quick save, like I said before, you might have to load all the entities back from that file so you can resume from the quick save point. So here's an example using the overworld map. So like, for example, Super Mario Bros. 3, the saved game is going to store all the levels you've completed, Mario's current status, like does he have a fire flower or is he small, etc. The current inventory, like he has 2 warp whistles and a star, for example. That's what you would save for Super Mario Bros. 3. When the game is loaded, Mario appears on the overworld map with all the completed maps showed and the inventory available. And so this game load might require, for example, quitting to the main menu, right? You might not let the player load this game unless they go all the way back to the main menu and then hit load. Or you might let them do it mid-fight, who knows? But probably not unless it's from a menu. In a quick save, what you would do is you press some sort of button and you save everything. All the data that's currently happening in your level. It's almost like you're taking a snapshot of your RAM at this point, and you're saving the RAM to disk That's almost what's happening. But just keep in mind that players can abuse this sort of quick save system in order to like never take damage. They can like save it when they see the boss shoot a bullet and then like reload until they've correctly dodged it. So I don't really recommend quick saving or quick loading. The last one is a password save. And the password save is fascinating. So what you would do is you would take your game data and you would hash it somehow. So you create a hash function, and that hash function either output a password right here. So maybe what you do is you take, like for example, in Mike Tyson's Punch-Out, I'm not saying this is how Punch-Out did it because I have a video on the next slide of exactly how it did it. But let's just say you took the current level and you want to change it into a password that the user can input, but not a password that the user can easily modify to cheat and get their way to the end of the game. So for example, let's say you're playing Super Mario World. If you had a passwords for Super Mario World, you wouldn't want it to just be how many levels have you completed, right? So like the password after you've completed 31 levels is 31. That will be terrible because then someone could just put in the password 96 and they'll be done the game. So what you want to do is take that value, hash it somehow, kind of randomize it, and then put out this big long password that someone has to remember. In Mega Man 2, the password save functionality created dots on a two-dimensional grid, which was extremely cool as well. So password save was done in a time where persistent storage was very difficult, right? So back in the day when you had an NES cartridge, in order to implement a save game, you'd have to have a battery in the game that physically kept the RAM in a specific state. And so passwords were a way around needing persistent storage because they could recreate where you were in the game from the password. Now, for the rest of the lecture, I'm going to show this like 5-minute video. I hope it works. It's an excellent video. And actually, you know what? Go to this video because we're over time already. I've already gone an hour and 20 minutes. So I'm going to paste this video in the chat, and you watching on YouTube can go watch this excellent video by Biscuit, and it's how he reverse engineered the NES Punch-Out password. And he has a whole series of videos on the reverse engineering of these. I don't want to freeboot his video, and we're already out of time. So let me just really quickly paste this in the chat. So copy link. Here is the video link out in the chat for people who are watching live. And if you're not watching live, please go watch that video. It's an excellent video, and it really makes you appreciate like what developers went through back in the day in order to get around these technical limitations. Awesome. So we just did game tools and drag and drop, and now we have everything that we need to know for assignment 4. So assignment 4, we're going to be talking about that on Thursday, and that's the same day that assignment 3 is due. And then you should have plenty of time, 2 full weeks to work on assignment 4. And remember, project specification. If you haven't done it already, November 16th, so just about 2 weeks from today, is when you have to have your project groups formed and your project proposal, 2 to 3 pages explaining what your group project is going to be about. Okay? So please get that in as soon as possible, because the sooner you get that in, the sooner I can grade it, and the sooner you can get started on your project. And also on D2L and on the Discord channel, I have put in a spreadsheet for you where you can sign up if you're looking for a group for the final project. So please do that. Thank you all so much for tuning in, and I will see you in the next lecture.